Today we'll be doing the sum from 1 to infinity of 2 to the n plus 1 divided by 3 to the n. And to start off, we could break apart this fraction into the sum from 1 to infinity of 2 to the n over 3 to the n plus 1 over 3 to the nth power, which is also equal to the sum from 1 to infinity of 2 to the n over 3 to the n plus the sum from 1 to infinity of 1 over 3 to the nth power. But we could also write this as the sum from 1 to infinity of 2/3 to the nth power plus the sum from 1 to infinity of 1/3 to the nth power. And now I'm going to make a change of index. So I'm going to let n equal k plus 1, which means that k is equal to n minus 1. But if n starts from 1, that means that k has to start from 0. So this is equal to the sum from k goes from 0 to infinity of 2/3 to the k plus 1 plus the sum from k goes from 0 to infinity of 1/3 to the k plus 1 power. And we could break apart these exponents into the sum from 0 to infinity of 2/3 times 2/3 to the k power plus the sum from k goes from 0 to infinity of 1/3 times 1/3 to the k power. And now we can write this as 2/3, the sum from k goes from 0 to infinity of 2/3 to the k plus 1/3, the sum from k goes from 0 to infinity of 1/3 to the k power. And you can notice both of these summations are geometric series. So we can invoke the geometric series formula, and we have 2/3 1 over 1 minus 2/3 plus 1/3 1 over 1 minus 1/3. And this simplifies to 2 over 3 times 1 minus 2/3 plus 1 over 3 times 1 minus 1/3, which is equal to 2 over 3 minus 2 plus 1 over 3 minus 1. 3 minus 2 is 1, and 3 minus 1 is 2. So we have 2 plus a half, but we can multiply the numerator and denominator by 2. And we have 4 plus 1 over 2, but that's clearly 5/2. So now I could say, therefore, the sum from 1 to infinity of 2 to the n plus 1 over 3 to the n is exactly 5/2. And that is the final result.